Today, I'm going to show you a way to eliminate an entire class of common AI code generation problems in 30 seconds. We're going to be introducing some determinism into non-deterministic generative AI. This is going to be the main idea I want you to take away from today's video. But on top of that, I'm going to give you a single command that you can run right now to generate your own really robust MCP server and start adding your own MCP tools to it in literally minutes. Now, if you haven't developed your own MCP server before, or even if you don't know what MCP is, don't worry about it. The single command I'm going to give you to generate your own MCP server is going to generate a project that will actually teach you what MCP is, in addition to helping you to add your own tools to it. So it'll be learn as you build. Now, it's the idea of injecting determinism that's important here. That's the key. You can apply this same idea to pretty much any framework, any library, any technology, any sort of development that you choose. Although I'm going to show you something really cool and something really useful that you can use to build and learn, really focus on the idea here and the power of it and the importance of it. We often have AI assistants try to do things that they really shouldn't be doing. We want consistency, we want reliability, and sometimes that means using a template or a script or something else. Now, all of it is a lot to explain, so instead of continuing to explain, I'm going to show you. I think you stick with me by the end, you'll get it. You'll understand how to build your own MCP server, you'll build your own MCP server, and you'll understand the power of this simple concept. Now, I develop a lot of MCP servers for coding the future. I also work on a software team at a startup called Saga, which you're going to hear more about in the future. We also develop a lot of MCP servers there. And what we find is that AI coding assistants currently make a lot of mistakes when they're trying to scaffold a new MCP server. There's a lot of nuances and things that can go wrong in subtle ways. Also, if the AI assistant could correctly scaffold one, you're guaranteed to get 10 different outcomes 10 different times. And what we want is consistent application of cross-cutting concerns and architectural design patterns across all of our MCP servers. Now, one well-known but not often applied approach to this consistency is the use of templates. And Python has a really great tool called Cookie Cutter that solves exactly this problem. So a few months ago, I developed a Cookie Cutter template for building MCP servers. And then later on the Saga team, we took that Cookie Cutter and we evolved it more to make it more robust and more feature rich. And by the way, shout out to Andrew, the CEO over at Saga, for coming up with some of the patterns you're going to see in our Cookie Cutter template, especially related to how we apply the decorator pattern. So what is Cookie Cutter? It's a Python tool. And it lets you create a directory structure with template files, template variables as placeholders. You can even have pre and post commit hooks. You can do conditional logic during the generation of the project from your templates. You're going to see a lot more about what I mean, but it's really powerful. It goes way beyond a static template, such as a repository that folks git clone and then have to make a lot of modifications. It has a lot of dynamic generation behavior that make it super powerful for this use case. As we said, Cookie Cutter expects a template in a directory structure format. So this is the GitHub repo for our MCP Cookie Cutter template. Now, you're not going to need to know a whole lot about this in order to use it to generate your MCP servers, but feel free to check it out in the GitHub repo. And soon we're going to be diving more deeply into MCP, the SDK, Cookie Cutter, and lots of other options for introducing some reliability into our AI assistants over in our school.com community. So if you're interested in getting more information, diving a lot deeper, please join us there. But the one part of our Cookie Cutter template I did want to spend just a moment on is this cookiecutter.json. That's a standard part of every Cookie Cutter template. So when we execute Cookie Cutter against our template, you're going to note it's going to ask us for a project name. It's going to ask us for a description, author name, and email, and a default server port. So that's being driven by this JSON file. I just wanted you to be aware that's what's going on. Okay, let's get on with generating our MCP server. You don't need to clone the Cookie Cutter template. All you need to do is install Cookie Cutter on your system and then point it to the repository that hosts the template. And remember the JSON file, so it's going to ask us a few questions. I'm just going to name our server sysutils MCP server. I'll go with the generated description, enter my email, and I'll just go with the default MCP port. So here you're going to notice that it not only generated our project, but it actually set up our virtual environment, installed the dependencies for us, noted that there's a configuration.yaml file for this MCP server that exists at that location. And then it's going to even give us some steps that we can use just to test out our generated server, because we have many example tools already baked into this that we can test with. So it says in a new terminal, go ahead and copy these commands. I already have a new terminal open. Okay, so the first thing we're going to do, we bundled a simple MCP client that just exercises our echo tool that's bundled in, just to make sure that everything seems to be working well. Okay, so we got back echoed hello world, so that's cool. Then it says, all right, the next thing is there's an admin UI that's bundled that's really helpful in developing and debugging and troubleshooting your MCP servers locally. So to run that, we can start another terminal. I'm going to do these separately. And we'll fire up the Streamlit UI, and you'll see what I mean. So there's a lot of useful stuff in here. Number one, first and foremost, is we bundle documentation right into the UI. Now, this is within the project separately. You can access that, but this is pretty handy. Give you a little bit of a quick start, some tips, some things that you can run to test some of the key files that you might want to look at inside of your new MCP server, how to run the test. And then we have a README developer guide, various guides here for you. This one in particular, we're going to come back to in just a minute, because it provides some instructions for you to use the built-in MCP inspector to test the example tools. So it also says we can test out our tools right away by adding, in a new terminal. Okay, so now this is the MCP inspector. We can actually connect to the new MCP server. We can go to the Tools tab and list all of the tools. So out of the box, we provide quite a few example tools that show various ways you can develop tools. So let's just do a quick test. We'll invoke the getTime tool. You can see that worked. Also, if we go back over to our admin UI, go to logs, and we actually log information to a local SQLite database. And we also have implemented a pattern that will let you send your logs to any backend that you want to, say Elasticsearch. All right, so if we take a look at our logs, we'll see the tool invocation for the getTime tool. And as I mentioned in the documentation section, we have a lot more documentation on how you can test all of these example tools. So first we provided information on launching the inspector, and then we get into each of the tools and give you some example payloads so you can experiment with this on your own. Okay, now, just because it's a lot easier to visually show you what's going on if we have an IDE, I'm going to launch Cursor. So let's CD into our new sysutils MCP server and open the new MCP server code base in Cursor. All right, so there we go. I'm going to go ahead and then open a new terminal as well. Okay, so let's take a really quick look at some of the elements of our generated MCP server. So here, you'll notice that the cookie cutter template had template variables as placeholders, but cookie cutter has gone through and taken our inputs and substituted that. Now, it's not just substituted at the directory and file name level, but there are several source files that had conditional logic, had those template variables as placeholders that it went through, including our documentation, and did all of that. Remember that it also had pre-generation and post-generation hooks that caused it to go ahead and set up our virtual environment, install our dependencies, et cetera. So our MCP server is ready to go. As you saw, it's already functional. We have example tools working. We have a UI for debugging and troubleshooting and looking at logs, et cetera, and learning. So what will probably be most interesting to you is the tools directory. So for the most part, when you add your own tools to this MCP server, you'll be only working within the tools module. And it's pretty straightforward. And again, we're going to show how that you can actually use what's in the project to help you add the tools and learn about the tools. So we're not going to go into depth here, but this is example tools file that basically contains Python functions. The getTime tool that we invoked is a simple Python function that is decorated as an MCP tool. And then we have random number, et cetera, et cetera. And when you create your tools, you're just going to create another tools file, however you want to organize it, but it's just going to be a set of Python functions that our framework will automatically decorate for you. Now, in addition to the tools, we also automatically generate a set of unit tests and integration tests. So if we go one level up and we open the test directory, you'll see that we have integration tests for all of the example tools. And we also have unit tests for the decorators that are part of our framework. And as I mentioned, not only do we build a framework that helps you scaffold and then helps you build the tools, we also include some custom Claude / commands that you can use to help you actually learn about MCP if you're new to it, or learn about the specifics of this particular MCP server in the framework, and also to help you add your own tools, which we're going to do in just a few moments. But this is what we're trying to do here is basically help you as much as we can generate your MCP server, but also teach you about MCP and how to add tools, but let you do it in a very straightforward and personalized way based on where you are in your learning. So the way we've done that is we've provided a custom or set of custom / commands for Claude. Now, from experience, I know that most of the time you can get away with dragging these same commands into Cursor and hitting enter if you're a Cursor user and you're not using Claude Code, and you will get a very similar experience. So feel free to do that if you don't want to use Claude Code. We're going to be sticking with Claude Code for this tutorial, however. But the way we've done it is we have a set of custom instructions that provide detailed guidance to Claude Code for each of these activities, such as let's figure out where the user is in their MCP journey. Are they brand new to MCP? Do they understand MCP? But we need to train them on our particular framework. And also, can we give them some help in adding tools to our example server and later on removing our examples so they clean it up? So in order to ground all of these tools or Claude in sort of reality, right? What we've done is we've created what amounts to really a local specific knowledge base that each of these custom commands refers to guide the user throughout the process. So specifics on lessons learned, what to do, what not to do, patterns to avoid, patterns we've implemented, how to add a tool, how to add a new decorator, those kind of things. So we want to ground our AI assistant, and we want to provide the reference implementation and the reference guides and the custom commands to make it more convenient for the developers. So to give you an idea of what I mean, in the terminal inside of our MCP server repo, I'm going to open up Claude. I'm actually going to use the dangerously skip permissions. It's up to you whether you do or not. If you don't, then Claude's going to prompt you a lot to ask whether it can implement or invoke a certain tool or take a certain action. And I don't want to clutter up the tutorial with that, so I'm just going to have it just execute the tools it needs. And remember the custom / commands, like for getting started. These are available to you, so you can execute just getting started. And just so you don't have to watch while Claude thinks through everything, I probably will speed up some of these sections. Okay, one of the things you can see that Claude is actually going in real time and looking at our reference documentation, looking at the actual project, because the project could evolve over time and we want reliable information, right? So you're presented with 3 options here. If you're brand new to MCP, you can enter 1, and it's going to assume no knowledge, and it's going to use the grounded information that we've stored in our reference section to educate you just a little bit on MCP, but also give you the option to say, I still don't understand that. Can you give me more information? So in addition to actually helping you build something, we really want to help you learn as you build. I think this is the new way that we will be doing things, right? You'll be able to build something quickly, but you'll be able to learn about it so that you can increase your skills and also move faster in the future. Okay, so it says MCP. It lets AI assistants use tools to do things, not just talk. Now, I'm not going to go through each of these because it's not the point of this video. The point of this is to make you aware of it, to give you just enough to get you started, and then you need to go through this exercise on your own. So I'm just going to say, yes, it makes sense to me. So I'll move on to another concept related to MCP in general. Then it covers server versus client. You're developing a server. Clear so far? Yes. Another concept, the various transports that MCP supports. Does this make sense? Yes. Okay. And then it says, okay, what are tools in Python? Well, in Python, a tool is just really a function. And it gives us a couple of examples. Any questions about the code? No. So from here on, I'm going to continue to iterate with this prompt, and then I'm going to stop and resume when I get to a point where I think, yeah, you need to actually understand this new concept. Otherwise, I'm going to blow through the rest of this. Okay, so it iterated, it provided some more information, educational material for us. I skipped through that part of it. You'll see when you exercise this. But it got to the point where it's like, hey, do you want to actually launch the MCP inspector, which we did once already, but it actually launched it for us and gave us a little bit of help to help us actually use it if we haven't used it before. So it'll say connect on the left side, list tools, and try out either echo or get time. And it actually has launched the MCP inspector for us. So I'll just show you connect, list tools, echo, hello, run the tool. Okay, so it will do that for you. So it's very proactive in that way. I'm going to go ahead and close this tab for now. Go back to cursor. So it says, when you're done testing, let me know and I'll kill the inspector process. I'm complete. So now I'll look for all the processes and it'll kill the inspector just for hygiene purposes. So we don't run into more conflicts and things like that in the future when we launch it again. It even gives us guidance on, hey, you probably want to close the browser tab for MCP Inspector because that's known to cause issues when you relaunch in the future as well. All right, so now we're ready to build our own tool. So what do? We're presented with options. Do you want to learn about MCP in general? No. Do you want to learn about our framework and the specifics of our framework? Yes. It took us through the entire process from end to end. We had the opportunity to ask questions, get clarification. And now you ready to add your own tool to the MCP server. So let's say yes. And what I'm going to do is we have another custom command for that, add tool. Now it's just going to be a simple system util kind of tool. Add a simple tool for retrieving real-time information on my OS CPU, memory, and disk I/O status. All right, so the add tool command has a lot of guidance in it to guide Claude Code to do the research, to put together a plan, to look at the code for the MCP server as it is, make sure it grounds whatever solution it comes up with in the way that our MCP framework actually works, to go out and use an MCP server called Context 7 if it needs to research current libraries, frameworks, or whatever to make sure it comes up with a viable plan that's grounded in reality. And then it's going to present us with a plan for our approval at the end. So you can see it's actually going out to Context 7 to search some of the libraries. It's looking for a library called psutil, which is the common library for interfacing with the OS CPU memory resources, things like that. So it's doing that research as we've directed it in our command. So it's done all its research and it's come up with a plan. So based on my research, we're not going to go through all this in detail because the point is not whether it's correct. It probably will be. But here are the parameters for our new get system status tool. So we're going to use the psutil version 6.1 library, follow async pattern. Here's some error handling, some key considerations, and then some expected payload output for our tool. And of course you could say, no, I don't approve it. No, I got some questions or whatever. But right now I'm just going to say, yes, I approve the plan. So it should move on to implementing the tool. So it's not going to modify any of our example tools right out of the box. It's going to leave those intact, but it's going to add an additional tool, the new with a get system status tool. Okay, so Claude says it's done and it's relaunched the MCP inspector. So we can command click or control click, launch the MCP inspector. We'll connect. Let's see if our new tool is there. So all of our example tools, as expected, are still there. Let's go ahead and try out our new get system status. So I'm going to toggle per CPU on, run the tool, and as you can see, it worked first try. So for simple tools, I found this custom command combined with grounding Claude in, hey, you've got to look at this, you've got to research that, understand the framework, understand MCP, understand the user's requirements, present a plan. I found this to work really well. Of course, if you have a very elaborate MCP tool that you want to add to it, you're going to probably have to iterate on the add tool a bit more. But for simple tools, it's pretty reliable. All right, I'm going to close MCP Inspector tab, go back to Cursor. And I'm just going to say, it asks me, tell me if it works, done testing, it works. All right, so it did all of that. It says, hey, your tool creation is complete. Here's the new tool and what it does. Would you like for me to generate tests for you? So if you'll recall, as part of the cookie cutter template, we already generate integration and unit tests for the example tools. But now we can invoke the generate test tool to have it generate test for our new tool. So I'm just going to go ahead and do that. Generate tests, tool name or module. I'm going to give it the name of our new tool here. So here's our test directory. So we should see some new integration tests appear in our tests. Notice the command says, hey, look in our .reference directory, which I mentioned before, that has grounding information for how it should generate our integration tests. So we have integration test patterns here, and we have Claude Code always refer to these patterns to make sure that it does it the way we need it done in our MCP framework. While we're waiting on Claude to generate our test, I did want to mention something. One of the primary goals for this template, this approach, really is to make it very easy for you to generate an MCP server that incorporates the hard lessons that we've learned over many months of implementing various MCP servers. There are a lot of different things that can go wrong. Sometimes they can go really well, but a lot of times one tiny difference, one tiny way that you import something can actually break an MCP server and make it really difficult to diagnose. So we're trying to make it as easy and reliable. So reliable is really important. Not just simple, but simple, consistent, repeatable, reliable. That's one of the tenets for these types of practices that we follow. That's our goal, so that we make it easier for you, not just to build, but to learn. And you can get into this virtuous cycle of not just getting the satisfaction of building something, but the satisfaction and value out of learning from building. It's not either or anymore. It's both in parallel together. All right, so Claude Code actually implemented the new integration tests for the new system monitor tool. I could see as it actually developed the test, it was referring to our patterns to make sure that it was grounded in alignment. By the way, almost none of this would be something you would have any chance in August of 25 of getting Claude Code to generate reliably, much less this quickly, using a vibe coding approach. It's just completely impossible. So what we're doing here is we're trying to provide as many rails as we can in his instructions and actually examples and reference material to Claude Code and forcing it to look and to tell us that it's looking and to formulate a plan and then follow it. And it's doing a great job with this. So in the end, it implemented get system status test, and it actually realized while it was running the test, oh, I missed an import. I got a little bit of something wrong, and it iterated twice, and it ended up running the test successfully. So we want to see the test ourselves. So I'm going to open a new terminal. I want to make sure I have the right virtual environment activated. All right, let's go ahead and run our tests. Hey, I'll just run all of the tests. So this is going to run all of the out-of-the-box example integration tests, the unit test, and also it's going to run our tests for our new sysutil tool. So there are quite a few of them. As you can see, our testing is quite extensive. And by the way, in the end, we've also got code coverage in here. So you're going to see that we have coverage metrics for our tests as well. It's already been generated once because Claude Code ran some of our tests already. So now we're going to be able to see a full report. All right, so all of our tests passed, 72 tests. Let's go ahead and take a look at our coverage just to prove we have it. Okay, cool. So we have coverage. We have only about 48%. A lot of that's probably edge cases. But if you look at the actual tool coverage for system monitor and example tools, we have close to 100%. So of course you can beef up the test. We'll be beefing up the test for the framework, the plumbing parts, etc. over time, but it's already built into everything in the template. Okay, so let's go back to our Claude Code session. It's educated us on the MCP now. It's educated us on our specific patterns for our MCP framework now. It has added a new MCP tool for us correctly the first time in one shot. It has generated unit integration tests for us for our new tool. It's ran them. It's launched MCP Inspector, gave us detailed instructions on how we can test our new tool in MCP Inspector. We're looking pretty good here. Now, once you get comfortable with this, now we've obviously provided a lot of variations of example tools for educational purposes, for test purposes, so that we can actually get you going quickly. However, at some point you're going to get comfortable and say, I'm not deploying your example tools. I need to clean up your stuff. So we provided a convenient remove examples, custom Claude command. Again, you could probably drag, in fact, I've tested this a bit. You can drag these commands as is into Cursor, hit enter, make sure you're using a good model like Claude 4.1 or Gemini 2.5 or GPT-5 or something like that. And it'll give you a very similar experience to Claude Code in this case. Now, having said that, I make no guarantees because I don't fully end-to-end regression test every single AI coding assistant. I'm just saying, Claude Code, if you want a reliable experience, use Claude Code. That's what we test. So it's cleaning up the example tools, if you'll remember. And there are tools directory. We used to have an example tools with all the 8 example tools we produce. Then we had these integration tests, which it's already cleaned up as well. They were in their own source file. So it's cleaned up all of that. It's going through the init files, looking for unused imports, making sure it preserves our system, monitoring tools, imports, et cetera, et cetera. So bottom line is when it's done, you're going to have a functional MCP server that's done all the hard work for you. It's helped you add your own tool, and it's done the cleanup from the example tools. You'll have tons of documentation, and I want to refer you back to the Streamline app, which you really should go through and look at. We use correlation IDs to track requests through and trace them through the tools, which we find very helpful. You can look at the log files, see all of the logs for the tools, and you'll see that they have correlation IDs. You can exercise the MCP inspector, you can do various tests, and then you can see the logs. But the most important part is the documentation section. So I really stress that you actually use this documentation and also use your AI assistant, right? You don't have to read everything. You can always direct your AI assistant cursor or Claude Code, anything that those custom commands don't cover, you could just say, review that document in MCP inspector. I want to test tool XYZ. Tell me how I do it. So I highly encourage you to lean on the knowledge that we have in our MCP servers and your AI coding assistant's ability to review that documentation and give you detailed guidance instead of you having to read heavy documentation. I think we're moving away from that requirement to say, hey, go read the README file, follow those steps. Go read the Getting Started guide, follow those steps. And more toward an AI-driven, educational, setup, installation sort of world. Okay, so as I promised when we started this, we were able to generate a functional MCP server with a lot of the scaffolding infrastructure and a lot of helpful information, custom commands to help you get started, learn, add tools, integration test, an admin UI to help you view logs, to troubleshoot, great documentation in 30 seconds. So we could dive more into this, and we will in our school.com community. So if you'd like to dive deeper into MCP in general, MCP SDKs, or these more powerful, as I see them, higher value lessons that we can learn to not have AI try to generate everything for us when it's not necessary, and also how to keep them on the rails by providing things like reference implementation, great custom Claude commands, examples, ask them to do research, that sort of thing. Give them patterns to follow. That's the higher value, and that's what I really wanted you to take away from this. Future videos, we could go into more detail into the mechanics of these things, but that's the one guiding principle. Don't have your AI assistants try to generate everything for you. Sometimes it's far better to use a script or a template or something that you already have, and then let the AI help you iterate on that to add your own unique features. If you found the topics in this video interesting, you'll likely find other videos on this channel helpful as well. And we'd love to meet you in our school.com community where we dive deeper into these topics. Also, if you have ideas for other topics or you want more information on this topic, please do let me know in the comments below. And if you enjoyed this video, please consider giving a like and subscribe. I'm Tim Kitchens, Coding the Future with you, and I look forward to seeing you in our school.com community and future YouTube videos.